Hello, my name is Marcin Wielgus, and today, together with my colleague Beata, we will give you an introduction to autoscaling in Kubernetes. COVID and coronavirus are probably the most hated words of 2020. They caused a lot of grief, sadness and sorrow. Many people lost their loved ones. The economy all over the world went to a standstill. Lots of business had to close. Almost everyone had to adapt to new sanitary requirements. In IT, we are privileged. We could move from offices to our homes and pretend it was business as usual. Computers were easy to move. Video conferencing had been there for ages. So, is it business as usual? Well, not really. As the world changes, IT needs to catch up. Usage and traffic patterns change. Some services' popularity skyrocket. Some barely get any interest. New features are accelerated to keep the business running. Migration to cloud is also accelerating, as keeping own data centers may become challenging should we have another round of lockdowns in the fall. And as many business and customers are struggling, margins are shrinking. Being cost-efficient has become much more important than it used to be. Companies want to pay only for what they really need now or may need in the near future to keep running. Unfortunately, nobody can predict the future, so adaptability and cost optimization may be the key to success. And this will be the topic of our talk today. During this talk, we want to help you to build a checklist and provide solutions to problems like: can my application adapt to changing traffic? Can I effectively manage resource consumption? Can my infrastructure adapt to changing number of pods, their sizes, to new application and their needs? Where can I almost effortlessly reduce costs? In other words, we want to give you a helpful hand. A bit of automated assistance, robotic guardians, so that you can have a bit of peace of mind in these challenging times. Let's start. The first robot I'm going to talk about is called Horizontal Pod Autoscaler. Horizontal Pod Autoscaler is based on metrics that express the load that the application gets. It can be either real CPU usage or something more custom, like the number of queries per second or other gauge-like value provided by the user. HPA takes the value of the metric, compare it with the user-defined target, and depending on the comparison, adds or removes replicas, hoping to move the metrics towards the desired value. Let's take a look on how does it work in practice. But before that, let me clarify something. While talking about HPA, I will use a word utilization. I understand it as a ratio between the current load, expressed by some metrics, and the maximum amount of load that the application can handle. For example, if a pod requested one CPU and is currently using only half of CPU, then the utilization is 50%. If pod can handle 1000 queries per second but is processing only 200 at this moment, then the utilization is 20%. Okay, now the mentioned example. In this example, we have 4 pods that are burning hot. They are reporting very high utilization. Their load is above the target. They also use almost all of their capacity. If the traffic increases, there might be not enough power to handle it. If we add another pod and the same traffic is spread across 5 pods, then the average per pod load will obviously decrease, leaving more space for spikes and coming closer to the target. If the situation is different, and for each of the pods the load is way below the target, it might be a good idea to delete a pod. Then the traffic on the remaining pods will increase, the pods will be better utilized, and you will have more free resources in the cluster. And this is what HPA does: adds and deletes pod replicas when needed. When to use HPA? HPA works the best with stateless serving workloads that can spin up new replicas reasonably fast. You can also use HPA with queue-based processing. How to enable HPA? HPA is part of core Kubernetes APIs. HPA is controlled by an HPA object. You can create this object either manually by providing a YAML definition or by a kubectl autoscale command. CPU usage is available out of the box. Custom metrics require a little bit more work. While setting up HPA, it's crucial to set the target value, or more generally, target utilization, right. 1 minus utilization is your spike capacity and the driver for scale-ups. Too small buffer may prevent scale-ups and may overload the application. Too big obviously causes waste. The value of the target utilization should allow you to run with the increased traffic but with the old number of replicas for, let's say, 2 minutes and still have a bit of buffer. So, if you expect that within any 2 minutes your traffic may rise by 50%, set the target utilization to less than 65%. If it can double, to less than 50, and so on and so on. What are the other best practices for HPA? Applications under HPA should correctly handle SIG terms. That means that after receiving the signal, the application should not stop but finish all of the requests that are in flight and still listen for the incoming connections that may arrive after the pod termination begins. It takes a while to update all kube proxies and load balancers, sometimes even 1 minute. If your application dies before all kube proxies and load balancers are updated, some requests may end up in the void, causing errors on the client side. You can handle SIG term signals by adding the appropriate code in your app or by putting something like slip 60 in a press stop hook. Also, your new replicas should not receive requests before they are ready for that. To ensure that, please set up readiness probes and liveness probes. It's a good practice even without HPA, but it is particularly important when your pods are constantly starting and stopping. Please keep your metrics server healthy. It is the source of CPU utilization metrics, and without it HPA will not work. Last but not least, please enable cluster autoscaler. While adding new replicas, you may end up without any free capacity in the cluster and you need something to fix it up. Also, when the number of your pods decrease, something needs to decrease the size of your cluster. As I said before, HPA adjusts the number of pods to keep the desired utilization. So, if your current average application utilization is 20% and you put this application under HPA with 60% utilization target, you may get up to 3x cost reduction, assuming of course that you enable cluster autoscaler. Now it is time for me to pass the mic to Beata, who will introduce you to the second helpful autoscaling robot, vertical pod autoscaler.
Thank you, Marcin. So we've seen that horizontal pod autoscaler cares for the right amount of pod replicas for a workload. Vertical pod autoscaler, however, recommends pod sizes. It constantly monitors the real CPU and memory usage of your application to estimate how much CPU and memory your pods should be requesting. The recommendation that it makes sure that the real usage is well below the requested resources. But why are pod requests exactly like boxes for cats? They should neither be too small nor too big. Pod requests are what Kubernetes scheduler uses to decide where to put your pods, based on how much free space a given machine has. The request is also what Kubernetes guarantees to provide to your application to run. This means that if the requests are too low, the scheduler may put your pod on a node that doesn't have enough resources to provide for your pod. This in turn can result in out-of-memory errors, workloads evicted due to memory pressure or your workloads underperforming due to not enough CPU available. Note that from the point of view of your customers, this is already an outage. On the other hand, specifying too big resource requests is very safe, but it causes you resource waste. You are not using resources that could otherwise be useful somewhere else. So let's take a look at this simple example. We have a pod. It uses 95% of the requested capacity for an extended period of time. It might also occasionally burst and use more than 100%. What VPA will do is it will recommend increasing pod size so that only, let's say, 75% of capacity is used. Another situation is if the load on the pods is very low for an extended period of time. VPA will recommend to decrease pod size and free some space. This will then allow for better utilization of your machines. VPA works in 3 modes. In the first one, it only provides recommendations, but it doesn't change actual resource requests. You may then choose to apply the recommended settings manually. In the second one, it only sets requests for pods that are newly created. It doesn't change pods that are already running. And the last one, third one, automatic mode allows VPA to evict an existing pod if it has suboptimal requests and recreate it with recommended ones. VPA is best suited to figure out usage patterns over longer periods of time. It's not tailored to responding to sudden changes of usage. For this, HPA is definitely the better tool. You can use VPA for both stateful and stateless workloads, especially if they are not a good fit for HPA. And with current implementation, it's important to remember that VPA tailors the recommendation to the majority of the workload's lifetime. So if you have a workload with, let's say, very short and a very hot startup phase, this may cause VPA to recommend not enough resources for your workload to be able to start efficiently. And lastly, the auto mode is useful if your application can handle restarts and if you gained enough confidence on the recommendations that you are getting using recommendation-only mode. VPA is not a part of core Kubernetes, so you either need to install it as an additional component or enable it in your Kubernetes managed solution, like for example GKE, and then you do it with the appropriate cloud provider specific commands. After you do that, you still have to create a VPA object pointing to the application that you want to scale. This is similar to what we've seen with HPA. However, here we have no dedicated kubectl command, but you can check out the examples of how to configure this in our Autoscaler repository. Now, some tips on what to watch out for when using VPA. As I mentioned earlier, you should start your advantage with VPA in recommendation-only mode. Give it a couple days, convince yourself that the recommendations that you're seeing are according to your expectations, and then consider switching it to auto mode. You should also always use pod disruption budgets to control how many pods can be restarted at any time. You should always do this, regardless of using VPA or not, but it is especially important if you're using VPA in auto mode. As a safeguard, you should always set minimum and maximum container sizes in the VPA object. And also keep in mind that VPA doesn't update the deployment spec. It only updates pod requests for pods as they are created. So a good practice is to take a reasonable pod request, like the one taken from VPA recommendation, and put it in the deployment itself. So just in case, I don't know, someone turned off VPA, you have a reasonable default to fall back to. As we said before, VPA tracks trends over time. So to do that, it has to store multiple days of history. That means that very significant changes should either be done gradually or they may even require a new VPA object. And to do this properly, you should also create a new deployment with a different set of labels. To function correctly, VPA takes its metrics from a metrics provider. By default in Kubernetes, this will be metrics server. it is very important to keep that metrics provider healthy for VPA to be able to function. And lastly, in the same way as with HPA, you should enable cluster autoscaler in your cluster to make sure that as the workload sizes change up and down, the infrastructure can react accordingly. Now, can you use both horizontal and vertical scaling on the same workload? The short answer is no. The more detailed answer, as always, starts with it depends and execute caution. Technically, you can always use VPA in the recommendation-only mode. It's safe. It doesn't change anything on your workloads, so nothing bad will happen to you. However, in order to have confidence in the results that you get, you should not configure HPA and CPU utilization and use VPA at the same time. The options that you do have is to either use custom metrics for HPA, like requests per second, or use absolute values for HPA targets if you want to scale on CPU. And you should always make sure that HPA gets enough traffic. So it should never be at minimum number of replicas for extended periods of time. Now, in the setup, switching vertical pod autoscaler to auto mode is a bit risky, and it shouldn't be done without deeper understanding of both HPA, VPA, and understanding your workload characteristics. So if you want to do it, we recommend extensive testing beforehand. Now, how does VPA save you money? If you use VPA, your workloads only request the resources that they actually need to run safely and efficiently. This helps you keep those costs in line and make sure that you are utilizing your infrastructure well. Without VPA, you just use your best guess. And what we've seen is that usually people, to be on the safe side, significantly over-provision, sometimes a couple times. Now, let's move on to the third and the last robot in our autoscaler family. This is cluster autoscaler. We've been talking about HPA and VPA, and they are both targeted at scaling user workloads. What cluster autoscaler does, it adjusts the underlying computing infrastructure. It provides nodes for pods that don't have place to run in the cluster, and it also compacts underutilized or empty nodes. It's important to note that it is based on simulation of scheduler decisions and declared pod requests. It doesn't use any actual dynamic metrics like usage or observed requests per second. We'll take a look at how it works in practice. So here we have simple infrastructure for nodes, for pods. 3 pods are big, 1 is small. And I would like to remind you once again that this size that we're talking here is coming from the declared pod requests. So for this one small pod that we're seeing, it leaves some free space on the node. So if a new pod comes, scheduler will see that it can actually fit into the third node, and that's where it will place it. There's no work for cluster autoscaler in this situation. However, if all nodes are kind of full, then the scheduler has no way of placing the pod. A new node is needed. And this is when cluster autoscaler kicks in, it talks to your cloud provider, and requests spinning up a new node. Like this, the new node is provided, and now the scheduler sees the new space and puts the pending pod on the empty node. Now, on some occasions, nodes might not be utilized to their full potential. If we take a look at this picture, there are small pods on the 3rd and the 5th node, and they have nodes for themselves. Cluster autoscaler's job is to notice that it can move the pod from the 5th node to the 3rd node, and this way, one node will become empty and can be safely deleted. Just like this. One simple trick to reduce your monthly bill. Now, when to use cluster autoscaler, here we also all have a short answer, and it's always. And what I mean always, if you have any infrastructure that is more complicated than 2 or 3 nodes, or if you have any changes in your cluster over time, like workloads coming and going, scaling up and down, you should use Cluster Autoscaler to make sure your infrastructure reacts to those changes. Cluster Autoscaler works with multiple cloud providers. You can see the list on the slide here. In addition to that, there are some cloud providers supported out of the core repository, which we as SIG-Autoscaling do not closely follow. Now, to enable Cluster Autoscaler in your cluster, you should follow cloud provider-specific guides. Some environments, like GKE, they have a built-in, easy-to-use switch to turn on Cluster Autoscaler. In others, they may require additional manual steps. Please check the appropriate documentation for details. Best practices when using Cluster Autoscaler: you should always use the hosted version of Cluster Autoscaler if it's available, as it is likely to be optimized for better experience. If you are managing your Cluster Autoscaler yourself, please pick the one that matches your cluster version. There may be some subtle differences between versions of Scheduler and Cluster Autoscaler, and this may result in some very subtle and very hard to debug issues. And lastly, again, define pod disruption budgets for your applications. We mentioned when discussing VPA that you should always do this, but for Cluster Autoscaler, it will let you control how often it can restart your pods when it wants to scale down a node. Now, for the fun part with savings, Cluster Autoscaler will usually drive your cluster utilization, measured in terms of the requested capacity, to something about 10% above the scale down threshold. And the scale down threshold is configurable, and by default it's 50%. So generally, you will see somewhere around 60% utilization in the cluster. If you're not using Cluster Autoscaler, your utilization depends mostly on your own bin packing skills. And on large clusters, that is actually really difficult. And what we're seeing there out in the wild, on average, it will be significantly lower than it would have been if you had Cluster Autoscaler enabled. Okay, we've met all the robots in our cute autoscaling family, and this talk is slowly getting to the end. So I would like to give you a little bit more information about SIG-Autoscaling itself. We meet every Monday. Most of our contributors are in Europe, so the meetings are held at 4 p.m. European time, which is unfortunately 7 a.m. at the West Coast. But we also have quite an active Slack channel where we talk all things autoscaling. And as to where our staff lives, new stuff like Cluster Autoscaler and VPA sits in the Kubernetes Autoscaler repository. HPA is the oldest autoscaler robot, and it sits in the core Kubernetes repo. And at this virtual KubeCon edition, we have a couple more autoscaling talks that we encourage you to check out. Just to mention two of them. There will be a SIG-Autoscaling deep dive with more in-depth description of Cluster Autoscaler and Horizontal Pod Autoscaler. And also there will be a autoscaling and cost optimization on Kubernetes talk that also will dive into advanced topics on Cluster Autoscaler and Horizontal Pod Autoscaler with custom metrics. And that is the end of the talk. Thank you very much for tuning in. And now we will have some time for questions.